leave it sitting like it is. Okay. It's cooling down.
Good morning. This particular little video is basically to show you how the plasma in a chamber relates to blowing up a tube here. See? Now I want you to watch that little balloon. And when you're watching that balloon, look very carefully at what's going on inside the chamber. What you'll see in there is you'll see the fact that we are creating a plasma. Now, the plasma we're creating in there is being done by way of the 3 arcs into a accumulator, and is the actual volume is roughly the size of a small pea. So we get this kind of reaction from doing nothing more than that. Also, I want you to pay attention to the color, okay, because the color is important in the process. As you can see, the color is more purple than white. So, that gives you a quick idea what all is going on here. And we can't leave it on too long because it has a tendency to draw a little more stuff than what we need. Now, actually, the circuit that, the driver for this test, and that's what this is a test, is our popper 2 board here, okay? And the popper 2 is basically just a grown-up version of the popper. The popper actually would create a similar effect. It's just that you can see the popper 2 is set up to handle 4 channels. Now, none of this has been optimized for anything. You'll notice that the coil here is wide open. It's not attached to anything. The radio frequency back here is not attached to anything. In other words, this is just a stock chamber that has a head in the back and it's filled with gas. There's nothing at all here to help this out. Now, a lot of people have said, well, they don't understand what the popper did. Well, the popper did the same thing, only it did it in 2 channels. This one actually has 4. We used 3 in this particular test. And the popper, the original popper, would... Oh, I also should have mentioned that nothing here has so far been fine-tuned. Remember earlier I said that the electronics have a tendency to get warm, as do the coils. And the reason for that is because we have not gone back in and set this for the proper dwell and things yet. We just thought we'd do a quick, let you see what's going on with it kind of thing. And now that you know what it looks like, well, the part 2, in part 2, we'll add the electronics for the chamber and for the chamber coil, and in part 3 we'll add the radio frequency, and at that point you'll get a chance to see just exactly what can happen here. Because as you can tell, it very definitely is quite active. It's just got to do it a certain way. And because we haven't done anything about the dwell, we also only get about 200 kV on our ball, so sometimes you'll see the balloon bounce harder than others, and that's because during that time they actually went to where they were supposed to go, and one of them didn't go errant like we have here. Okay? So, that's about as open as we can be with this thing, I think. Good luck, and I'll get back to you later on. Thank you. Oh, yes, you'll notice that the arcs are not white. That's very important, and if you think that it's not important, then go have a look at all of the plasma information that we have up for videos and what those colors should be. Okay? Because all that white you see from the heat builders that make the can and the can thing work and the rest of that, okay, is showing one of the basic limitations that the actual PAP circuitry has. In other words, the PAP circuitry will go terribly bad at some point. We won't get into that now, we'll get into it later. Okay? Alright. So, off we go. Thank you. I just wanted to, like I say, make sure you understood that this is just first crack out of the box here. We haven't done anything at all to optimize anything. We just threw it on here and told it to go. Thank you.